This is the video for Math 117, Section 3.2. Last time we were doing derivatives with a product like this, and we would have to distribute in order to do the derivative. But now we have a couple of new rules for products. Last time we had to distribute. We distribute the square root of x. We distribute here. Sometimes it's easier to go ahead and distribute, but sometimes you can't actually distribute and get any better derivative. You actually need the product rule. So the product rule is the next thing we look at. The product rule says, and these are the formulas we had before, the product rule says if I have a function times another function, I can take the derivative by doing the derivative of the first times the second plus the first times the derivative of the second. This formula is essential to memorize. Now note that the quotient rule looks very similar, but it's going to have f prime g minus, since there's a negative exponent here somewhere, that's going to show up somewhere, minus f g prime all over g squared. So two new rules. We'll be working with these exclusively for today. So if we go back and revisit this one, we really could have done this derivative a little differently. So instead of doing x squared minus 3x times x plus 7, we could have just done a product rule. So let's revisit this with the product rule. So x squared minus 3x times x plus 7. So y prime would be the derivative of the first. Now if you want to, you can go over to the side and say which all your pieces are. So you're thinking, I want fg prime is equal to f prime g plus fg prime. So my f here is the first one, x squared minus 3x. And my g is the second one, x plus 7. So f prime would be 2x minus 3 from our last, and g prime would be just 1. So when I take the derivative, I'll have, basically I start here and go this way, and then go up and down. So start with f prime, I have 2x minus 3, and I need a parentheses. Around these, I need a set of parentheses. 2x minus 3 times x plus 7. And then plus, that's what it says in the formula, f, which is x squared plus minus 3x, times g, which is 1. Now if I fold this out, I can see I end up with the same derivative. If they don't ask you to simplify, you'd be done, and you could leave it like that. But if you fold it out, you see you get the same derivative. So you could take the derivative by distributing this, or you could take the derivative by using the product rule. On this next one, they ask us to use the product rule. We know the derivative of g, we'll put it there. We know the derivative of h, we'll put it here. And then we'll do just what we did on the problem I just did. So we'll have f prime is g prime times h plus h prime, whatever we write in here, times g, or g times h prime. So we'll need 12x for g prime. H prime we have 1. And for f prime, it doesn't say to simplify. I could simply write f prime is g prime, control C, control V, times h, which is x minus 3. So I need parentheses, control V, plus g, which is 6x squared, the first one, times the derivative of the second, which I could go ahead and put in the 1 so that for later understanding I know what I was supposed to put there. But you don't need the 1. So each one that we do with product rule is just the derivative of the first times the second plus the first times the derivative of the second. Sometimes it's easier to remember the words of what you're doing for the procedure than what it is to remember the formula. So let me work another product rule formula, just example here. This is my f, this is my g. So y prime is equal to f prime. I need the derivative, which is 21x squared plus 6x minus 4. It needs to be in parentheses, times the g, the second one, x cubed minus 3x plus 1, plus the first, which is 7x cubed plus 3x squared minus 4x plus 8 times the derivative of the second, which is 3x squared minus 3. Note that I just wrote down exactly what was there for these two middle. F prime g plus g, f g prime. F prime g plus f g prime. Derivative first times the second plus the first times the derivative of the second. So they are having you do the same thing here. F prime g plus f g prime. You don't have to simplify. It doesn't say you have to multiply them out, so don't do that. It just is more time than it's worth. Now we're ready to start doing the quotient rule. So let's do a couple of examples with a quotient. So this is the quotient rule. This is f prime g minus f g prime over g squared. And some people remember this as low d high minus high d low over low low. Low d high minus high d low over low low. And I just remember the formula. It's the derivative of the first times the second minus the first, well, it's actually the top minus the bottom minus the top over the derivative of the bottom times the derivative of the bottom over the bottom squared. Or denominator prime numerator minus numerator denominator prime over denominator squared. So this is my f over g. You're going to recognize it if you'll actually put it in there. We could do the little block that we had. F is equal to x squared plus 3. G is equal to x minus 8. F prime equals 2x. G is equal to, G prime rather, is equal to 1. We start here and go like that. So we're doing y prime equals, starting here is 2x, parentheses x minus 8. Don't forget the parentheses, I'll take off. So make sure you're putting them in where you need them. I could put them here, they're not necessary, so you might get in the habit of putting them everywhere. Minus the top, which is x squared plus 3. And we're right here now. The parentheses and the derivative of the bottom, which is just 1. All over the bottom squared, the denominator squared, which would be x minus 8 squared. Sometimes I'll put the denominator squared first, so I make sure I'm writing that down correctly. Because once I have a bunch of stuff sitting around, I want to just pull from somewhere. So sometimes I'll do this part first, because it just makes more sense to do that. For numbers 14 and 15, they were going to be wanting an equation of a tangent line. And remember that the equation of the tangent line will be m times x minus x1. And in this case, our x1 is 3 plus y1, and our y1 is 3 over 2. So I need the slope here. Because I didn't ask for the derivative first, you could just find the slope by methods in your calculator. So we'll go to y equals, put in our formula. Now when we're putting a division here, you're either going to have to use the fraction button, which is alpha y equals. Some of you have that capability. Or you're going to have to make sure you put parentheses everywhere. The implied parentheses every time you have a fraction is that the numerator has a parentheses around it and the denominator has a set of parentheses around it. So the ones here in the denominator are required for this problem. The ones in the numerator are optional. If you don't understand the difference between where they're optional and required every single time, then you might want to always put them both in the numerator and the denominator. That's the safest way to do it. So now we want the slope of the tangent line, which is the derivative. Second calc, the derivative, which is 6. And we want it at 3. So we'll type 3. Remember that one doesn't give us anything. It just blinks there. It's blinking at me like I'm supposed to know what I'm doing, and I do. And I end up with the derivative is 0.75. So in here I would put 0.75, or 3 divided by 4. So my slope is 0.75 also here. Up here you'd have to find the equation of the derivative first, because that's what they asked for. But you could just get the f prime. You could get this one automatically by going and putting it in. It doesn't ask for an equation, but I could put this into y equals and find the derivative with other means. So that's a way to check your work too. It's not cheating to put that in to the calculator. It's using all the tools that are available to you to figure out what the answer should be. You're analyzing what the problem is. So here you have to find the derivative because they're asking for the formula. Down here they did not ask you to find the derivative, they just wanted the equation of the tangent line and the slope at a particular point. So you didn't have to find the derivative first. For 16 and 17 you can use your calculator again. Remember that down here you're going to need parentheses, or at least around the denominator. You don't really need them on the numerator. They didn't give you the y equals here, so you need to make sure you're putting the whole equation. And I'll ask you to find an equation, and when you write it, it needs to be y equals or y minus y1, whichever way you're thinking about it. I do not need it in y equals mx plus b form. Make sure that you leave it in a way that it's right. If you go on and do y equals mx plus b and make a mistake, I count off, even if you have the correct line there before you continued working the problem. You're overworking the problem at that point to put it in y equals mx plus b form. So business calculus is really about business applications. So now we look at applications for what we're doing with derivatives. So we have a demand function and we want to know its derivative. So you need to find the derivative of this formula. Note that the derivative of the numerator is going to be 0 rather, because that's just a constant. So make sure you're doing your f prime g minus fg prime over g squared formula and putting it in here. And then they want you to find the derivative here. Now these you can do on your calculator in your y equals menu. Note that this is 18, so you'd have to change your x max rather, to be 18 so that you could actually calculate this. So I'd want it 18, oops, not 51. So I know I'd have to change my x max in order to get that derivative in here. Notice that they say round to 2 decimal places. So you can spend a lot of time plugging things in, or you can use the full functionality of the tools that are given to you, which you will be doing in business. So make sure you're doing that to end up with the correct answers here. When the demand for watches is 5,000, the unit per watches is decreased by. So this is saying, what does this mean? It's decreased by something per 1,000 watches. So whatever this number is here, you're going to put down here. But the decreased already has the negative, so it may be that it doesn't want the negative there. So try that. These say decreased by so many, so I don't think you're going to need the negative. These will be negative values. On number 19, I do not ask for a derivative. It is asking for how fast is the unemployment rate of the country changing. Well, this is the unemployment rate function, and the derivative is how fast things are changing. It's the slope. That's what the slope means. So when you're looking at the rate of change here, it's just the derivative at the beginning of 2013, which t equals 0 is 2010, so that would be t equals 3. So I really want to put it in my calculator, y equals, I want it at t equals 3. So put that formula in, second trace, dy dx. In number 20, they want you to find the rate at which Glenglove's population is changing with respect to time. So here they actually want the formula. They want the formula. They're asking, what will the population be after 10 years? Well, that's putting that back into the population formula. What will the population be is about the population itself. So you're going to have to put that in. Once you put this into y1, then you'll be able to find what the value is by doing the value. So that's that second trace, and you see the first one is value, and you'll put in 10. Now the rate is the derivative, so they'll want the derivative, so that would be dy dx. So you'll be using two of these functions when you put p into y equals. You'll be using the value for the population, and you'll be using the dy dx, which is 6, for the rate.